everyone, thank you for signing in and watching my live stream. I'm Mr. Matt, and this is Dr. Tot. Dr. Tot, cookie for class? Okay. And welcome to Geometry. We're going to continue our preparation for the Semester A exam. This is part 6 to the live stream 1. Remember that I want you to use these live streams as well as practice exam A. That'll be linked in the description as diagnostic tools to understand which areas you may need to improve upon prior to the exam. After, if you see anything that you need that causes you trouble or is confusing to you, you can look for the independent practice problems and quick drill set A and B that'll be posting soon with more examples of these specific subtopics that we'll be going through today. Independent practice problems is a exercise that's a rather large exercise at varying difficulty levels, and quick drill set A and B will be focused on harder problems and word and real-world scenarios whenever possible. So check those out. If you have any questions, you can feel free to post them in the live chat function or in the comment section below if you're watching the recording. If you find these videos helpful, then please like, subscribe, and share with your friends. I appreciate it very much. And welcome to all the new subscribers. I appreciate you guys as well. Let's go ahead and I'll share my screen with you. Just a reminder, these are live sessions. Actually, let me make it a little bit smaller. So these are live sessions, so there's a little bit of a delay with the iPad, but I'll try and mitigate that as much as possible. I'm also available on all of my social media accounts that are linked in the description below. If you have any questions or recommendations for videos, just let me know there. And the document for today's lesson is going to be posted on Certified Learning Center's website. Just make sure that you're looking at the document, and that link will be in the description to this video as well. Just make sure that you're looking at the document that has the reference number 2049-24. And I'm going to be circling it there in a second. I'm so sorry, the iPad is giving me some trouble. Let me try and disconnect here. The screen's going to go blank for just a second, and then I'm going to reconnect. My apologies. There we go. So that should be working now, coming online. So just make sure I circle the reference number just so it's clear. Hopefully, there we go. All right, thank goodness. So if there's any questions, just let me know. Otherwise, let's get into today's lesson. So today we're going to be focusing on triangle proofs, miscellaneous proofs that involve triangles. Remember that our similarity postulates, we have the angle-angle similarity postulate. If you're able to match up two corresponding angles as being similar to each other, then you know that the triangles themselves are similar. We have the side-angle-side similarity postulate. So if you have a side, an included angle, and another side, if those sides are proportionate to each other, then you know the triangles are similar. If the sides are congruent, then the triangles are congruent to each other. So side angle side is one of the postulates that's a little bit tricky because it's both similarity, it can both prove similarity and congruence, depending on whether the side lengths are proportionate or equal, congruent to each other. If the side lengths are proportionate, then the triangles are similar. If the side lengths are equal to each other, then the triangles are congruent. And then the same is true for side, side, side. So if we're able to prove that three corresponding sides between two triangles are proportionate to each other, then we know that the triangles are similar. If we know that three pairs of side lengths between two triangles are congruent to each other, then we know overall the triangles are congruent. So side angle side and side 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 are both similarity and congruence postulates. In addition, we have the angle side angle and this angle angle side congruency postulate. So if you have an angle, the included side, and another angle, then they are congruent, then you know that the triangles overall are congruent. and the same thing is true with the angle side. And then the last thing, just to refresh your memory, we have this postulate: congruent parts of congruent triangles are congruent. So if you're able to prove with any of those postulates that the triangles overall are congruent or similar, then you know corresponding side lengths are either congruent or proportionate, respectively. If you have any questions, then let me know. Otherwise, I'm going to give you 4 minutes to look at question number 1. I'd like you to create a 2-column geometric proof to justify the following statement using the given information for triangle ABC and triangle DEF. The given information is triangles ABC and DEF are right triangles. Angle B is a right angle. Angle E is a right angle. Line segment AB is congruent to line segment DE, and line segment BC is congruent to line segment EF. I'd like you to prove that line segment AC is congruent to line segment DF. You might want to start by drawing a diagram just to get your bearings on this question, but I'm going to give you 4 minutes, and after 1 minute I'll start to solve. I'm going to keep track of the time in the upper left-hand corner, and I'll do my best to update the time per minute. Okay, so looking at number 1, first we could start by drawing a diagram. That always helps if they don't provide one. So we're talking about two right triangles, ABC and DEF. Then they tell us that angle B and E are the right angles, so I labeled those appropriately. And then they say line segments AB and DE are congruent, so I have one hash mark to represent their congruency. And then they say that line segments BC and EF are congruent, so I have a double hash mark to represent their congruency. Starting with the definition, the given information rather, that angle B is a right angle, we can say that the measure of angle B must therefore be equal to 90 because of the definition of a right angle. Same thing we can do with the given information about angle E being a right angle. We can say in step 4, statement 4, that the measure of angle E is equal to 90. And therefore we can say that the measure of, angle B must be congruent to angle E because all right angles are congruent. Then I stated the given information that line segments AB and DE are congruent in statement 7. Statement 6, and then statement 7, the other given information that line segment BC is congruent to line segment EF. Then I've just stated, I've proven all of the information needed for side angle side. So I know that triangle ABC must be congruent to triangle DEF because I have side angle side congruency. And if I know that these two triangles are congruent, I can say that line segment AC must be congruent to line segment DF because congruent parts of congruent triangles are congruent. CPCTC as an abbreviation. If you have any questions, please let me know. Otherwise, let's look at question number 2. So I'd like you to create a 2-column geometric proof to justify the following statement using the given information for triangle ABC and triangle DEF. So here triangles ABC and DEF are right triangles. Angle B and angle E are the right angles. And the measure of angle A is equal to the measure of angle D. I'd like you to prove that AC is similar line segment AC is similar or proportionate to line segment DF. I'm going to give you 4 minutes, and after 1 minute, I'll start to solve. Okay, so here, if we state that angle B is a right angle, we can then say that angle B must have a measure of 90 degrees because of the definition of a right angle, and the same thing for angle E, setting up that angle E and angle B are congruent because all right angles are congruent. So we first need to prove that they're right angles because their measure is 90 degrees, and because they're right angles, they must be congruent to each other. Then they tell us that the measure of angle A equals the measure of angle D. So angle A has to be congruent to angle D because of the definition of congruent angles. And therefore, we've met the criteria for angle-angle similarity. And so we know that triangle ABC must be similar to triangle DEF because of the angle-angle similarity postulate. And here, if we know that ABC overall is similar to triangle DEF overall, then corresponding parts of similar triangles would also be similar. So the definition of similar triangles would tell us that AC is if AC is corresponding to DF and the two triangles overall are similar, then the two line segments must be proportionate. If you have any questions, then please let me know. Otherwise, let's look at question number 3. So please create a 2-column geometric proof to justify the following statement using the given information for triangle ABC and triangle DEF. Triangles ABC and DEF are right triangles. Angles B and E are right angles. Line segment AB is similar or proportionate to line segment DE, and line segment BC is proportionate to line segment EF. Prove that line segment AC is proportionate to line segment DF. I'll give you 4 minutes, and after 1 minute, I'll start to solve. Okay, so here, if we start with the given information that angle B is a right angle and define the measure of angle B to be equal to 90 because of the definition of a right angle, and then do the same thing for angle E, that establishes statements 1 through 4. And then we also know that the given information, oh, I'm sorry, let me squeeze this in here, actually. We need to make sure that we say that the measures are equal, that the angles are equal to each other. So let me just say 5, that angle B has to be congruent to angle E because all right angles are congruent. Sorry about that. So that would be 6, this would be 7, that would be 8, and this would be 9. So we established that they're all equal to 90 degrees because they're right angles, or both of them are equal to 90 degrees. Their measures are equal to 90 degrees because they're both right angles by the definition of a right angle, and therefore those two right angles must be congruent to each other because all right angles are congruent. Then we also have the given information that line segments AB and DE are proportionate, as well as line segments BC and EF are proportionate. So therefore, we have all the information needed to say that triangle ABC must be similar to triangle DEF because of the side angles side similarity postulate. And because these two triangles are similar, the two corresponding side lengths of line segment AC must be proportionate to the line segment DF because of the definition of similar triangles. If you have any questions, then please let me know. Otherwise, let's take a look at the next problem. So please create a 2-column geometric proof to justify the following statement using the given information for triangle ABC and triangle DEF. We have given line segment AB is proportionate to line segment DE. Line segment BC is proportionate to line segment EF, and line segment AC is proportionate to line segment DF. I'd like you to prove that the measure of angle A is equal to the measure of angle D. I'll give you 4 minutes, and after 1 minute I'll start to solve. Okay, so this guy was a little bit more straightforward. Starting with the three given statements of these corresponding line segments being proportionate to each other, we can immediately prove that triangle ABC has to be similar to triangle DEF because of the side-side-side similarity postulate. If we're able to prove that three corresponding sides between two triangles are in a proportion to one another, then we know that the two triangles overall are similar to one another. Then we can tell that that angle A must be congruent to angle D because of the definition of similar triangles. If two triangles are similar, then their side lengths are proportionate and their angle measures are congruent. And therefore, if the angles are congruent, then their measures must be equal to one another due to the definition of congruent angles. If you have any questions, then please let me know. Otherwise, let's look at question number 5. Please create a two-column geometric proof to justify the following statement using the given information for triangle ABC and triangle DEF. Given the measure of angle A is equal to the measure of angle D, the measure of angle B is equal to the measure of angle E, and side length AB is congruent to side length DE. I'd like you to prove that side length AC is congruent to side length DF. I'll give you 4 minutes, and after 1 minute, I'll start to solve. So if we start off with the diagram, you'll see that you have two angles and an included side. So this looks like it's going to be angle side angle if we're trying to prove congruency. If we start with the fact that the measure of angle A is equal to the measure of angle D, we can therefore say that that angle A is congruent to angle D because of the definition of congruent angles. Similarly, we can say that because the measure of angle B is equal to the measure of angle E, that angle B must be congruent to angle E because of the definition of congruent angles. Then we also have the given information that line segment AB is congruent to line segment DE, and that gives us all the information we need to say that triangle ABC is congruent to triangle DEF because of angle side angle. And if we know that these two triangles overall are congruent, then we can say that the two corresponding side lengths AC and DF are congruent because corresponding parts of congruent triangles are congruent. CPCTC. If you have any questions, as always, please don't hesitate to ask. Otherwise, let's look at question number 6, and this will bring us up to the end of class today. Please create a 2-column geometric proof to justify the following statement using the given information for triangle ABC and triangle DEF. We have that line segment AB is congruent to line segment DE. We have line segment BC is congruent to line segment EF. And we have line segment AC is congruent to line segment DF. And I'd like you to prove that the measure of angle B is equal to the measure of angle E. I'll give you 4 minutes, and after 1 minute I'll start to solve. Okay, so number 6 was using the side-side-side congruency postulate. So instead of the similarity postulate, now we're using it to prove congruency. So if we know that line segment AB is congruent to line segment DE, and line segment BC is congruent to line segment EF, and line segment AC is congruent to line segment DF, all because that's given information, then we have enough to prove that triangle ABC must be congruent to triangle DEF because of the side-side-side congruency postulate. If these two triangles are congruent, then we know corresponding parts of congruent triangles are congruent, CPCTC. Therefore, we can say that angle B must be congruent to angle E. If angle B and angle E are congruent, then that must mean that their measures are equal. So we can prove that the measure of angle B is equal to the measure of angle E because of the definition of congruent angles. If you have any questions on anything that we've done today, then please don't hesitate to ask. If you find these videos helpful, then again, please like, favorite, and share with your friends. And if anything was confusing, or if you want some more exposure to any of these subtopics, look out for the independent practice problems and the quick drill sets A and B that will be posted soon. There will also be practice exams 1, 2, and 3. 1 you should use as a diagnostic tool before you start your preparation, and practice exams 2 and 3 should be used to fine-tune your skills right before the semester A exam. Well, I hope you guys have a wonderful night. And Dr. Tot, do you want to say goodbye to everybody? Come on, you want a cookie, Dr. Tot? Dr. Tot, you want a cookie? He usually never says no. Come on. You want a cookie? Can you say bye to everybody? Can you say bye? That's kind of bye. Can you say, there you go, there you go, good boy. All right, thank you guys very much for watching. I hope you have a wonderful night, and I'll talk to you all tomorrow.